you kind of know that on a globe, the South Pole is not spread out like that. You also kind of know that it loops back on itself. But what that particular projection is essentially what you get when you loop it into a cylinder, not into a sphere.
Okay, but everybody knows that this map is not to scale.
It's very much not to scale. The top of it is widely distorted, and the bottom. It's reasonably accurate around the middle, and it does give a reasonably good idea as to what the continents look like. I agree that it does. But some flat earthers will look at that and think that's what the world looks like. And the trouble is there's no consistency. So some will say, no, it's circular. Now, if to look at that map, if you start off with Southern California, I'm not sure where that is exactly. If you could put your cursor on the place where Southern California is, and then head for Korea, that'll be kind of helpful. Just head west towards Korea.
Okay.
You go off the edge of the map, obviously, because it loops. So back onto the other side, then.
You'll be about right here in reference, right?
Yep. Yes.
You'll be right here, and then it'll hit Korea right here.
Yeah, that's right. Go on, draw that one on as well. Go on.
Okay.
There you go.
It turns because it's 2D.
A continuous straight line, east or west, or depending which way you're going, obviously. In your case, it was going west. And you recognize that on a globe, that straight line on the Mercator map represents a circle around the Earth from California to Korea. Now, if you let me see. Let's just if you consider the North Pole to be a central point, and everything radiates away from it, where would you see that? If you look at the flag of the United Nations, for example, that's an azimuthal equidistant projection. So it puts the North Pole in the center and lays the land masses out around it, which is what the world would look like if you looked at it directly from above the North Pole. And as such, the line between Korea and California there would simply form part of the circle around the North Pole at that latitude, but it would still be the same direction, which is west. And it would your compass would show west, and you would expect it to show west because north is to your right. This particular map was developed interestingly. Historically, this map was developed for a particular reason, and it's so that when you do draw straight lines on it, they cross all the meridian lines at the same angle. If you do a diagonal line, for example, South Africa to South America, from the northern part of South America there, South Africa to
you said South Africa to you said South Africa to
America. If you do that from the bottom of South Africa up to America, North America, it's a diagonal line. And it crosses all the meridian lines at the same angle.
It's hard to draw it straight out. It's 2D, but yeah.
Yes, right, that's straight enough. If you actually did that in the real world, you would actually, your route would kind of be a bit like a corkscrew in the sense that it directly curves. It's not a straight line. That's not a straight line on a globe. That's only a straight line on the Mercator map because of the way the scale works.
I know, but that's what I'm trying to use. I'm trying to use the logic of a flat Earth map, right? What I'm saying is, say that the Earth was a disc, right? Like, reconsider this as a disc. All right, I can even scale that a little bit.
Well, tell you what, just pop onto your Google for a second, all right? Type in, I don't know, do a search for Gleason AE map, okay? You'll recognize it when you see it. As soon as you see it, you'll go, oh, now I know what he means. Gleason, Gleason, Gleason AE for azimuthal equidistant map. All right, you should get a picture up. If you can grab that, then paste it into Paint. We can both look at it together.
Tab out. It's gonna tab out. Do you want the northern?
Northern.
I'm just gonna.
Yes.
Okay. All right. Hold on, I gotta find one that's going to not be very pixelated. Hold on, because I gotta zoom in to actually find it. This is it's not gonna render very good on Paint.
Don't worry about it. Give it a go. Give it a try. We'll see what it looks like. All right. Might come out better than you think. Make it a bit bigger. There we go. We've zoomed. Lovely. If you start at California, yeah.
Okay.
And if you were to draw a straight line to Korea, that clearly isn't going east. But if you follow the curve of the horizontal, the round lines of latitude that you can see, if you were to follow that curve, running parallel to it from California to Korea, do you think you could draw that on there?
I mean, yeah. I'm just gonna. It's not gonna. It's gonna look like shit. This is the reason why. It's gonna look like that. So it's gonna keep turning. That's what I was trying to tell you. It's gonna keep turning.
It does keep turning, but what direction is that? That direction is west.
That'd be.
It's going along.
That wouldn't be west. That'd be northwest.
Well, no, it's not northwest. Though,
okay, so look, I'm